Hello students, welcome to BTech first year physics course. Now today I am going to start vector calculus, and this is very important topic in physics. And it will help us to understand mathematical description of fields such as gravitational field, electromagnetic fields, etc. So let's start. Now in vector calculus, we will discuss different topics. First, we will start with ordinary integrals of vector. Then line integrals, and here we will understand the concept of gradient. After that, surface and volume integrals. And here I want to mention that I will discuss solution of many problems related to ordinary integrals, line integrals, surface and volume integrals, to understand how to perform different types of integration involving these line, surface and volume integrals. Okay. After that, divergence theorem of Gauss, and from here concept of divergence. Okay. Then Stokes theorem and concept of curl. However, the concept of curl I have already introduced in bridge course in electrostatic, right? And last but not the least is Green's theorem in plane. Okay. And the book which will be followed is Theory and Problems of Vector Analysis by Spijey. So let's start with ordinary integrals of vectors. Although you have read it in your 12th class, let me quickly remind you what it is. Okay. Suppose Ru is a vector and it depends on a single scalar variable u. For example, time is such type of scalar variable. And here these R1, R2, R3 components are all dependent on u, and they are continuous in particular interval. Then this integration is called indefinite ordinary integral. Now if there exists a vector Su such that Ru is actually first derivative of Su with respect to u, then integration Ru du will give Su plus an integration constant, that is c, right? Now if we perform the integration between an interval of upper limit b and lower limit a, then the integration value will be value of Su function at b minus value of this Su function at a, right? And this is the concept of definite ordinary integrals of vector. Okay. Now we will discuss some problems and their solution to understand how to perform ordinary integration of vectors. Okay. And we will call this practice learning by doing. Okay. So let's start with first problem, and that is this: if RT is of this type of form, then we have to find out RT dt, this indefinite integral and this definite integral. Now let's do this indefinite integral. Now for that we have to divide this integration in component wise, right? This I cap, then 3t square minus t dt plus j cap 2 minus 60 dt minus k cap 40 dt. Now if we do this integration, then we get this form. Now here this C1, C2, C3 are different constants. Okay, and after that finally we get this form. And here this integration constant C is actually the combination of C1, C2 and C3. Now let's do that definite integral. So in that case we get this division of components, right? So after integration, if we put this limit, then we get this form, and finally we get 50i minus 32j minus 24k. So you already know how to put the limits in integration, so that I am not discussing here. This is very straightforward. So finally we get this form. Now next discuss this integration. So the problem is evaluate 3 sin u I cap plus 2 cos u j cap du, then integration limit is 0 to pi by 2. So for that again we have to divide this integration in component wise. So this is I cap 0 to pi by 2 3 sin u du plus j cap 0 to pi by 2 2 cos u du. So always you have to remember that as you have vector, you have to divide the integration, total integration in component wise, different components. So if you do integration of sin u, then we get minus cos u, and the limit is 0 to pi by 2. Then if we do integration of cos u, then we get sin u. Now if we put the limits, then we get this final form 3i plus 2j. Okay. Next, discuss this problem. The problem is the acceleration a of a particle at any time t greater equal to 0 is given by this form. Now, if the velocity and the displacement are 0 at t equal to 0, then we have to find out v and r at any time, any instant of time, that we have to find out. So for that, as we know the acceleration is dv dt, then v will be integration a dt. Now in place of a we have to put this form. Then if we put this form, then after integration it will be minus e to the power minus t I cap, then minus 6 t square by 2 plus t j cap plus 3 minus cos t k cap, and then one constant c1. And here we have to find out this c1, and for that we will use this condition that velocity is 0 at t equal to 0. So let's do that. So at t equal to 0 velocity is 0. So if we put t equal to 0, then the right side equation will be minus I plus 6j into 0 minus 3k plus c1 equal to 0, because in the left side there was the velocity v. Then we get c1, that is I plus 3k. And if we put this c1 in the form of v, then we get this form of velocity. This is the final form of velocity. Now, as the velocity is first order time derivative of displacement, the displacement will be integration v dt. Now in place of v, if we put this expression that I have put here, then if we do the integration, it will be t plus e to the power minus t, as there was already one minus, it will be plus, then I cap minus 3 t cube by 3 plus 6 t square by 2 j cap plus 3 t minus 3 sin t k cap plus c2. This is another constant c2. So to find out c2, what we have to do? We have to use that condition that displacement is 0 at t equal to 0. So let's use that. So if we use that, the right side term will be I cap minus j into 0 minus k cap into 0 plus c2 equal to 0. So c2 we get minus I cap. Then if we put this constant in the expression of the displacement, then you get this form. So this is the final form of the displacement at any time t. Okay. Now let's discuss the next problem, and that is we have to evaluate integration limit 2 to 3 a vector dot d a vector dt dt, and here the vector a at t equal to 2 and t equal to 3 are given. We have to use this form, okay, to find out this integration value. So to proceed, let's write a vector dot a vector is a square, right? That we know. Now if we differentiate it with respect to time, then it will be like this, and we get a vector d a vector dt equal to half d a square dt. Now what is the importance of doing this? That will be clear from the next slide. So this is the expression, this is the integration we have to solve, and here if we put this form, then this half will come out from the integration and we get d a square, and a square is a vector dot a vector, and this is differential a vector dot a vector. So this is similar to dx, right? Integration dx. If we do the integration of dx, it will give you x. So here also we get a vector dot a vector, and limit is 2 to 3. Then if we get this expression, now already the vector value at t equal to 3 and at t equal to 2 is supplied in the problem. So we get this form. So 10 value we will get. So this is the final value. So today we have done solution of various types of problems, right? And I believe that it will help you to understand the various types of problems involving line integral, surface, as well as volume integrals, which we will discuss in the subsequent classes. Okay. So today we will stop here. In the next class, I shall discuss what is line integral, the definition of line integral, and its importance, and what is gradient, the concept of gradient. Okay. So thank you for attending today's lecture. See you in the next class.